Hey there. Thanks for being there with AI Neuroski, where we learn with AI and master the future. 3D printing is often described as this miracle technology that's going to completely replace factories and rewrite our global supply chains. But here's the truth, and it's a bit more complicated than that. 3D printing is incredibly powerful, yes, but it's also very limited at the same time. Today, let us peel back the hype and talk about the real limits and the current reality of 3D printing. The single biggest misconception is this idea that 3D printing is about to replace mass manufacturing. In reality, it's just not designed for that. It isn't built for high volume, low-cost production. When you need millions of identical parts, traditional methods like injection molding are still way faster and significantly cheaper. The old-school factory isn't going anywhere just yet, so what are the specific limits holding it back first? Let's talk about speed and scale. Compared to processes like injection molding or metal stamping, 3D printing is slow, very slow. Printing a single, complex part might take several hours. Now, imagine you need to print thousands, or even tens of thousands. That could take days or even weeks. This speed issue alone makes 3D printing completely unsuitable for large-scale consumer products. At least for now. While the technology is getting faster, it's not even in the same league as traditional mass production when it comes to volume. Second, there are serious material constraints. You simply can't 3D print with everything. A lot of the more common 3D printed plastics are weaker and less durable than their manufactured counterparts. They can be sensitive to heat, sunlight, or repeated stress, making them unsuitable for many demanding applications, of course. High-performance materials for 3D printing do exist, things like metal alloys or carbon fiber composites, but these materials are extremely expensive and often require specialized printers and tightly controlled environments to work with, pushing the costs even higher. That brings us to the third limitation, the cost reality. While 3D printing can save money on things like warehousing inventory or shipping costs, the act of printing itself is not cheap. Industrial-grade printers can cost hundreds of thousands of dollars. The raw materials, as we just discussed, can be pricey. Add to that the energy consumption of the machines and the need for skilled operators to run and maintain them, and the costs add up very quickly for many companies. This means 3D printing is only economically viable for low-volume runs of high-value, specialized parts. And finally, limit number 4 is quality and certification. This is a huge one. In critical industries like aviation, healthcare, or automotive, every single component must meet incredibly strict certification standards for safety and reliability. The problem with 3D printed parts is that their quality can vary from print to print, depending on things like the printer's calibration, the ambient temperature, or even the humidity in the room. This variability makes getting consistent, large-scale certification a massive challenge. You can't have a crucial airplane part that might be slightly different every time you print it. So, with all these limits, where does 3D printing actually shine? It excels in very specific, high-value areas. Think about creating on-demand spare parts for old machinery, which saves companies from holding huge inventories. It's perfect for rapid prototyping, allowing engineers to quickly test and iterate on new designs. It's a lifesaver for producing emergency replacements in remote or hard-to-reach locations, like on an oil rig or even the International Space Station. And its greatest strength is creating highly customized or geometrically complex designs that are simply impossible to make with traditional methods. This is where 3D printing adds real, undeniable business value. So, the real future isn't about 3D printing replacing factories. Instead, the future is about hybrid supply chains. We'll see a smart combination of both worlds, centralized mass production for the things we need in bulk, and decentralized, local 3D printing for situations where speed, flexibility, and customization matter most. In this model, 3D printing becomes a powerful, strategic tool in the supply chain toolbox, not a universal replacement for everything else. Truly understanding technology means knowing both its incredible power and its practical limits. If you want more realistic, no-hype insights into the future of technology and AI, make sure you subscribe to AI Neuroski. Together, we learn with AI and master the future. Thanks for watching.